Hello, welcome to the fifth lecture. We are going to or continue to talk about the words, and we will talk about one particular thing related to words, something which is called co-location. Uh, and this is a fifth lecture because if you, some of you are confused, the fourth lecture, although I have not sent any video recording of that, but that was sort of the reading assignments related to studying about subword tokenization from the Jurafsky book. And I think that has sort of explained very nicely about one particular subword tokenization called as byte pair encoding. So please read it carefully, and also you will see that I have already posted assignment, first assignment, and the first assignment, one of the questions is related to the byte pair encoding. So you have to implement that. And regarding few things on the assignment one, if you see for some of the questions you will have readily available codes on the net. For example, the byte pair encoding, there will be several codes available to you. But my, it's for your own betterment, and it's for your own better understanding. My suggestion would be to implement by yourself. First, try to understand the algorithm. It's very easy. It's not very difficult. Uh, you have done coding much difficult than this, so it should not be difficult as per se for coding. So try to understand how you can try to understand the methods and then try to code it by yourself. So let's begin with this lecture. Before beginning to the this lecture, let's recap that what we have talked about in the last lectures. So we talked about that what are the basic resources you need and what kind of a basic pre-processing required. So we talked about corpora, different type of the corporas, and then the text normalizations, where we specifically focused on the word segmentation. I discussed the heuristic approach and ask you to go through subword segmentation or subword tokenization by going through the Jurafsky's book, particular section. Sentence segmentation, heuristic approach we have discussed, and then we have talked about the lemmatization, systeming, and morphological parsing. So, the first assignment is based on whatever we have discussed until now and what we are going to discuss today, uh, and maybe the next one or two classes. So today we are focusing on the two things that we want to analyze and understand that whatever the tokenizations we have done, and then using that we try to understand certain features of the corpus. So what are the things we should ask, and what are the things and what advantage and why we should actually look at those things, and then we will move to the co-location. So let's assume that you have created your own corpus. You have done some basic text normalization steps, and now you want to understand the characteristics of this corpus. So now, what are the basic things you can ask? And see, this is not with only with the text data or this kind of a corpus, but also it is true with any kind of a data you are going to work in machine learning or in natural language processing domain or anything related to dealing with the data. You should always try to first understand the raw data. What is there, and what are the features are there? What kind of a noise are present? Because unless you understand the raw data, in fact, this is one of the most neglected aspect of the data. I think I have mentioned this again and again, and I will mention this now, and perhaps I will keep mentioning this a few more times, because one of the thing is there that once you get a result, you need to analyze that. or if you want to come up with the new model, understand you until you understand the nuances of your data, it is very difficult to come something very novel from your own. You will perhaps by looking at the papers and looking at the some others perspective, you will sort of try to adapt your model or something. So that's very important. And understanding this corpus, the nature of this corpus, and these are few things which is very very important. So some of the basic questions you can ask, and then we can also sort of say that why it is required. So let's first understand what are the basic questions you should ask. So, for example, what is the length of the corpus? How big is the corpus? How many distinct words or the tokens are used? What are the most common words? What they do signify? Uh, so now you want to perhaps wondering that why this is required. So I will try to give you one or two examples to sort of make you understand that it is why it is essential. Uh, First of all, it is going to give you a lot of insights about your data. For example, I don't give you any clue that what kind of a data or where this data is coming from. Uh, so to understand the writing style, so that is one thing. What kind of a vocabulary, what kind of a different type of a word has been used, so that you need to understand. And as you will sort of see later on, as we keep discussing about, for example, language models, you will see that this becomes very very important. That what is the your source data on which you are trying to train your language model, and in what kind of a data you can actually expect that this language model will work well. So this writing style, the kind of a vocabulary which has been used, that has to be sort of understand very well, because words, for example, used in Wikipedia text are not similar in the words which have been used in news articles, or the words used in research articles uh, are not very similar to either of the, let's say, the Wikipedia text or the news articles. Words used in the social media is different from any of these three things: news articles, Wikipedia text, or research articles. Of course, there would be some overlap, but then there would be a lot of words which are not present in, which are only present in one of the domains. So we will see that this out of word vocabulary makes a huge problem. And if you have for example trained your model on one kind of a data, and you want to see that similar kind of a models should work on other kind of a data, you will face some difficulty. So that is why it's I try to understand that, when you look into this corpus, by looking at just the vocabulary and what kind of a word, it already gives you some sort of a clue that where some characteristics of the data, and then you can understand that what where this the source domain it is, how you can sort of adapt this for the different in other domains or other kind of a data, and so on. So uh, and yeah, and then some more important things. See, for example, you might have heard about that. There are this natural language, in chat box where people try to generate some answers, and or on Twitter, based on the tweets, they are trying to automatically generate some sort of a responses and so on. So there were some notion that okay, some very famous big models which try to sort of started giving the words which are very very abusive, and so on. So why that has happened? Because the kind of data it was trained on, perhaps that it has a lot of such kind of words present in those kind of contexts. And especially in the social media, it's a platform where there can be a lot of abusing, the bullying, and that kind of issues. So the words reflects those things, and that is why these automatic, the generation of the tweets, the bots which try to sort of write those sentences, has also got bias. And to understand, for example, these gender bias, why the automatic machine generated sentences tend to use some of these kind of the abusive words. So those things can be only understood, or can be explained when you look back to the data on which you have trained and what kind of a vocabulary is there. So before we continue, just I want to emphasize and I want you to sort of recall the two very important definitions. And while in initial discussions it might uh, lead to some of the confusion. Right? What do we mean by word? What do we mean by tokens? So tokens are the sequence of characters that are grouped together as a usual or sort of as a useful semantic unit for further processing. And so that's what, and this token may not exactly be the same as what we call and understand as a word in a normal sense. So uh, so it's a kind of a sequence of the characters which you have after during your pre-processing step of the tokenization. You said that okay, these sequence of the characters you are want to group them together as a single unit for further processing. So that is your tokens. And when we talk about these tokens, so we also do one more thing, that we consider each occurrence as a distinct unit. And the types, when we talk about types, that are the they are the class of the tokens having the same character sequence. So in that way you are considering each one each so in the token, when we are talking about the tokens, we are considering them as a distinct, the separate occurrences. But when we talk about types, so if they have the same character sequence, they will be counted as the single occurrence. So it's basically the what are the distinct tokens which are occurring in your corpus. So those sort of refers to the types. So here's an example when we try to sort of understand that what kind of words which are present in my corpus. So here's an example taken from the foundations of the statistical natural language processing by Christopher Manning and Henrik Such. And so they have considered a one particular corpus. It's the story written by Mark Twain called Adventure of Tom Sawyer. And in that particular corpus, they looked into that what kind of words are there and in what frequency those words are happening. And in what they have seen that there is about 71,000 word tokens and 8,018 word types. So the distinct uh, the token class, which were about 8,000. So distinct, the words in a kind of a little bit of a loose sense, you can say that distinct words are about 8,000 and 71,000 was the tokens, the total number of words. So what do we observe here? So look into the left side of the table, and you see that you know most of these words are what we call is the function words. So function words are basically you have these giving some sort of a grammatical role, playing grammatical role such as preposition, determiner, auxiliaries, verbs, quantifiers, and so on. So they are actually dominating over the content words. So the content words are basically which actually carry some real meaning. So the nouns, adjectives, and so on. So those are the ones which actually carry meaning. But those are in this particular case, what you see are very less, and in fact, almost all of them in this particular table, what we see, and of course, this is not the complete list of the words, but these are the most frequent, about I think 10 to 15 words. And what we see is that perhaps only one or two uh, content words are there, and rest all are function words. Function words basically belong to the closed class, as they are almost fixed. There's no new function words are being added or removed, so they remain fixed. So they are called a closed class. On the other hand, the content words are, what we call is, they belong to the open class, and because we keep adding new content words, or some of the words are being removed, uh, and the content words are, with the existing words, we have these kind of, you can add prefix suffixes, and that lead to the change of the meaning, and so on. So those are the content. So this analysis shows that the majority of the words are the function words, and very few content words are present. Again, if we want to do some sort of understanding of that, what is the distribution of these words, and if we try to make some sense of it, uh, before looking at the distribution, if you just want to look into the, if you just calculate the average uh, frequency of the words, so then you will see, perhaps in this particular case, they have calculated, and that says it's about 700. So that says that each word types is occurring about 700 times. So what you see is that it has completely changed the meaning, and just looking at you know average occurrence is going to mislead, and then it does not give the correct information. But what we see here is that uh, primarily what we see, that some words are very common. So there are a few words which are very, very common, and those words, we know that most of those words are basically the function words. And then we have these many rare words, and that's what we say, that this uneven distribution, and this long tail phenomenon. Long tail indicates that there would be many, 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 the words which would be appearing, but then with a very less frequency. And just imagine that if you want to, when we will talking about these out of word vocabulary issues and all, and one of the ways to handle some of those things is that you try to sort of remove some of the words, or you want to put them into a single class, uh, mm, based on certain pattern and so on. So then you will realize that many of those, these rare words is going to group together, and then each of those ones will have a very common. For example, if you are learning the word representation, vector representation of those words, so then you are going to group a large portion of your words into those categories. So that is why this simple analysis is important, that where you should put the such kind of a boundaries and all. Uh, and also, then there were about 90% of the word types in this particular example occur 10 times or less. So that is again indicates that the very the vast majority are occurring very infrequent. So people try to sort of understand, and that whether there is some sort of a relation, and one of the mm, main contributors in the early days of, let's say, that this corpus linguistic analysis, GIFT, he tried to understand this kind of an observation, and he came up with this formula where he says that the frequency uh, of a word type and its rank based on frequency. So the rank is also based on frequency, and then the frequency itself, they are sort of the inversely proportional. Okay, so you can say that the 50th most common word should occur with about 3 times the frequency of the 150th most common word. So that's the what this Gibbs law try to understand, or try to say, and that is the sort of the based on this kind of an observation in multiple corpora. Uh, and more or less, it's a good description of the frequency distribution of words. And based on this, in fact, there's a lot of study related to this. And if some of you are interested, just get a glimpse of that, how this kind of analysis, different, domain related to the literature who studies the language, try to sort of infer this relation. And one of the things the Jeeps try to explain this uh, relation between frequency and the rank is what he calls the principle of least effort. And what this essentially says that, as a human being, we want to perform or do uh, or we want to complete a task by putting least effort. And it is very natural for as a human being. So and that is also true in this kind of the language learning, and when we speak and when we listen. So how do we sort of explain this observation through the lens of this principle of least effort? So what this sort of says that the speaker effort is conserved by having a small vocabulary of common words, and listener's effort is lessened by having a large vocabulary of individually rare words. So the idea here is that the speaker wants to convey his message very clearly, unambiguously, and the listener's objective is to understand uh, whatever is being said unambiguously. So whatever I am saying, so that my effort, my uh, attempt is to use the words, or when I'm trying to explain, I should be using the word which are very, I mean, which is highly likely that you already know those words. So that to do that, I will try to, you know, again unconsciously, I will try to use very small set of the words, so that you already, I mean, making this probability that you already high, that you already know those words. And as a listener, your objective would be to understand whatever I am saying. So what you will try to do is that you will try to keep a very huge vocabulary of the rare words. So even if I am speaking some words which are rare, and just using one or two times, but to understand it completely, you should know those words. So you will make sure that you know those words. So that is why your tendency to keep a large vocabulary of rare words, and my tendency to keep a while explaining, use a small vocabulary of common words. So that's what the way the GIFs try to sort of explain this kind of an observation which are there uh, in any kind of a corpus. So, but there are certain issues. So, for example, when Gibbs law was fit on a brown corpus data, so what is an observation made here is that In the middle range, this fits very well, but in the top, the words which are occurring very frequently, those words uh, were not fitted so well, and that is also true with the words which are rare. So to take care of this aspect, the mental plots has sort of tried to generalize this and try to fit relatively better, and gave some modified that relation, and added few more parameters which sort of reflects some sort of a richness of the text use of words. So that's where try to sort of take care of the fitting at the top and the bottom end of the word frequency. So that's the kind of an end of it that I wanted to sort of just describe, that having a very basic analysis on your corpus is going to be helpful, can give you a lot of insight, and it's essential to do that. When we talk about out of vocabulary words and issues related to that, when we talk about uh, we may not talk about in this particular course, or when perhaps you, while you are doing some project, you will try to see when you want to do some sort of a transfer learning on domain adaptation, then you will realize that such issues occur. So I mean, those things become very, very important. So this is the first part of the lecture. In the second part of lecture, I will talk about collocation.